So I've been wanting to do a lecture on a recorded lecture on electrical safety, and so this is it. And this is what we're going to start with here. And these figures here really, I think, encapsulate everything that I want to get across. And I wanted to have this available so that we can, I can refer everybody to this. And you can look at this on your own time when and how many ever times you want to take a look at it. So I want to start this discussion with what we know of as qualified and unqualified. Now, when it comes to electrical safety, the NFPA 70E is not the governing authority, but it is a publication that the governing authority, who is OSHA, will refer you to when it comes to putting together an electrical safety plan. What I want you to know is what are the industrial requirements for you to maintain electrical safety in a job place. All OSHA really says is that employers have to create a safe work condition. Employers have to provide a safe work environment. And that encapsulates a lot of things. We're going to talk about electrical safety right now. Okay? And basically, let's start by breaking people into what we're going to call, or what the NEC and the NFPA 70 calls qualified and unqualified. And it has nothing to do with electrical training. Well, I shouldn't say that. It has nothing to do with electrical classifications, such as an IBEW, International Brotherhood of Electrical Workers, journeyman. The definition does not include that. Doesn't include a bachelor's degree or an associate's degree in electrical engineering or electrical engineering technology. It's a very basic definition, and the 70E and the National Electric Code basically says you're qualified if you are trained in the installation and operation of electrical equipment and the hazards involved. Okay? Now that's not verbatim the definition from the National Electric Code and 70E, but it's close. It serves our purpose. And unqualified is basically all others. And I believe what really happens is when a company comes in, says you're going to be an electrician, they're accepting the fact that they're calling you a qualified person. So most importantly, you need to be continuously trained in the installation and operation of electrical equipment and the hazards. Okay, I guess I should have an equipment in there. And most importantly, we are going to talk about the electrical hazards that exist. Okay, so to continue on, the 70E defines these things that we call approach boundaries. And let's start with the limited approach boundary. Limited approach boundary is a boundary only to be crossed by qualified personnel. And unqualified personnel are allowed to cross if escorted by a qualified person. Now, a couple years ago, the NFPA 70E simplified a couple of things, and they removed what used to be called the prohibited approach boundary, and now they go with what's called the restricted approach boundary. And that's an approach boundary that unqualified people are not allowed to cross, period. And qualified are allowed, but you have to have your what's called your proper PPEs. And PPEs stand for personal protective equipment. For industrial applications, which is what we're going to talk about, we're going to limit our discussion, and you'll see why in a minute, to systems that are between 50 and 750 volts. Okay? Now, and that's how our approach boundaries are broken up. The reason I use this is because in industry you will see very common 480 volt systems, 208 volt systems, in my mind the most common. You'll also see two 40 volt systems and 120 volt. Doesn't matter whether they're three phase or single phase. Of course, 120, 240 you see in a home as well. The limited approach boundaries, these boundaries are governed by those voltage levels. The limited approach boundary for this classification is 3 feet 6 inches. Okay? So if you're going to open up a panel board in industry that's got an exposed, what we call an exposed energized circuit part, what they call it in the 70E. The limited approach boundary, if you're not qualified, if the company you're working for hasn't given you the stamp of approval that you're qualified, then you're not to cross that boundary of an energized conductor. And that's going to happen immediately when you open up a panel board. So, nor anybody that's not qualified should get any closer than 3 feet 6 inches. The restricted approach boundary is 1 foot or 12 inches. Okay. You're allowed to open up a panel board. There's a couple of exceptions here on PPEs. You're allowed to open up a panel board and look if you're qualified and if you're only going to look and observe. But the minute that you enter the 12-inch, if you're going to troubleshoot or reach in and grab a conductor or something like that, which some people do, the minute you enter 12 inches, then you've got to have your PPEs on. And what I would like to do to begin this discussion about PPEs is let's start the discussion of what the NFPA 70E calls establishing an electrically safe work condition. And it is a 6-step process. If you've worked in industry and aren't aware of this process, you simply know it as shutting things down. Well, the 70E makes this an official process. And rather than me just writing each step, I thought I'd copy and paste it from some PowerPoints that I've put together on the matter. And this is the process. Number one, determine all sources of electrical power. Normally there's just one feed, but you got to be careful from time to time. You'll have some boxes that'll have more than one feed into them. Number two, then you open each source, where you just open your switch or a breaker that feeds your cabinet. Where possible, you confirm that the switch is open. By the way, that's rarely possible, especially if it's a circuit breaker. You can't physically see the open contacts. Then apply electrical lockout according to ZES plant procedures. ZES stands for zero energy state. That's an expression that a company uses that I've done some work with. I suppose it's a very common expression. I know where I first ran across it, ZES, zero energy state, and lockout. We're not going to get into lockout, tagout, but if you go to work in a company, you should be, as an electrician, should be issued a lock to which you have the key, and that is your key. And then the sticky point here then is we have to, once we open things up, we have to test it for the absence of voltage. Now, as a part of that process, you have to confirm that your voltmeter works properly. So you have to measure the voltage that is there to begin with. What I subscribe to is that you measure, if you can, you measure the voltage exactly where you're going to be removing the voltage. But there's different ways, methods of approaching that. And then when you throw the switch, then you measure the voltage that it's gone. All three phases, phase to phase. Let me write it this way. All three, and phase to neutral. All three is the proper way to do that. And then, where applicable, you apply grounds. That's not always applicable. Now, the very process of measuring for voltage or absence of voltage is in of itself an electrical hazard. So when you do that, you have to be familiar with what it is that you need to know to protect yourself. And I break it into two things. I just simply call them shock and flash. Okay? Shock protection, bottom line is hot gloves. Anytime we're measuring greater than 50 volts, we have to have hot gloves. If you're an experienced electrician and haven't been accustomed to that, that's sometimes a hard pill to swallow, but that's our standard of today. A lot of companies have embraced that and do it very well. Sticky point with hot gloves is that rubber insert has to be tested every 6 months if you're using them. If you have a pair of gloves that have simply been issued, or they're not issued for use, but sitting in storage, it's 12 months. But they do have to be recertified to keep it official to the 70E. The last thing that we want to be concerned with then is what is flash protection. That also gives us a third boundary, which is called the flash boundary. And the flash boundary is a distance at which a second-degree burn can occur on the system where you're at. Second-degree burn means that you're probably going to be off to the hospital or somewhere to treat a boil that has been created. So that's the number, or that's what we use as the standard here. And the measure, what we use to measure what it takes to make a second-degree burn is what's called the incident energy. And it takes an incident energy level of 1.2 calories per square centimeter to create a second-degree burn. Another way to look at that is 175 degrees Fahrenheit for 1/10 of a second will also create a second-degree burn. And at this point, I just want to say that I'll put together another video that will explain the flash label, and that will conclude our electrical